My name is Lucas Videtto, and I'll be presenting on machine learning with big data, challenges and approaches, written by Alexandra Leherau, Katerina Grolinger, Haney Elimani, and Miriam A.M. Capretz. The main issue addressed in this paper is understanding the challenges in machine learning posed by big data. There has been an explosion in data volume, velocity, variety, and veracity. Volume being how much data, velocity being how fast new data is coming in, variety being the range of data types, formats, and structures, and veracity referring to abnormalities in the data. More traditional machine learning techniques were designed for smaller and more uniform sets of data, with many assumptions being made. These assumptions include the data fitting entirely in memory as well as the data being available at the start of processing. Problems arise with scalability, processing speed, and data diversity and quality. This inefficiency leads to delays and decreased accuracy due to simplified models, making it hard to gain meaningful insights from big data. Thus, there is a need to advance machine learning techniques to take full potential of what big data has to offer. Now we'll discuss previous work this paper discusses and builds off of. Beginning with Najda Fabadi, who identified obstacles in machine learning such as unstructured data, data quality, and scalability. This points out how traditional models typically have inefficiencies. Next, Jiao focused on big data and signal processing, addressing issues like data speed and diversity, and demonstrated how domain-specific challenges can further complicate machine learning applications. Now, Aljara reviewed approaches to increase the efficiency of algorithms in terms of both speed and memory in order to handle big data without getting overwhelmed. They discussed new algorithm approaches aimed at reducing computational complexity. Now for the technical details of the paper. First, MapReduce, which is a programming model that processes large data sets with a distributed algorithm on a cluster, and Hadoop, which is a framework that supports data-intensive distributed applications. This enables the processing of large amounts of data across several machines, which reduces computational time and memory problems. Next, online and incremental learning techniques allow for models to learn from streaming data, updating dynamically as data processing occurs. It supports real-time decision-making and learning without the need for retraining the model on the entire set of data. Finally, there is leveraging deep learning for data variety and veracity. Deep learning has the ability to learn abstractions from data, making it effective at handling unstructured and complex sets of data, improving the accuracy of models dealing with clustered sets of data. For the results discussion, starting with scalability and processing performance, we saw that technologies like Hadoop have addressed the challenges of volume in data and results showing a reduction in processing times, allowing for larger data sets to be used. Online and incremental learning techniques have allowed for real-time data analysis, and how deep learning methods have done well at extracting meaningful insights from big data. The integration of these approaches have transformed data analytics, leading to measurable improvements in real-world scenarios. Finally, for the conclusion. Traditional machine learning methods have been inadequate for the scale and complexity brought on by big data, affirming the necessity of machine learning techniques to address those challenges. New techniques such as Hadoop and deep learning have indeed increased our ability to gain practical insights from big data, yet there is still a need for further research. This further research is needed to refine these methods and develop solutions in order to fully leverage big data for real-world applications, especially in machine learning, and advancing the world around us. Thank you.